A candidate dengue vaccines while it's a Tightrop. Definition: the most advanced candidate vaccine against dengue virus is called CYD-TDB is progressing toward potential registration and review by the World Health Organization in 2016. CYD-TDB is a formulation of four hemolytic yellow fever 17D vaccine viruses, each one engineered to express the surface envelope and PRM membrane protein from the 1 to the 4 serotypes of dengue virus.
Transmitted by mosquitoes, dengue fever is a threat to almost half of the world's population. Dengue is a major public health problem, particularly in Latin America and Asia, where outbreaks occur regularly. When biting a person for its blood meal, an infected mosquito releases saliva containing the dengue virus. Once in the body, the virus infects the immune cells in the skin tissue. And enters the lymphatic system. The viral infection can then trigger a strong inflammatory reaction. During the incubation period, the virus first replicates locally. And then spreads into the bloodstream of the infected person. This is called viremia. For some patients, especially children, the infection may cause severe forms of the disease, including dengue hemorrhagic fever. The blood vessels become permeable, resulting in plasma leakage. Ultimately, dengue hemorrhagic fever requires intensive hospital care. When a mosquito bites a person who's already infected, it draws in the dengue virus contained in the blood. By biting another person, it can transmit the virus and spread the disease. The vaccine contains 4 strains against the 4 types of the dengue virus. Once in the body, the vaccine activates the immune system and the production of antibodies. The immune system is activated in 3 steps. The dendritic cells capture and carry the vaccine strains through the lymph vessels to the lymph nodes. They activate T cells,
Applications in medicine. The surface envelope protein is a target of virus neutralizing antibodies. The safety and the efficacy of CYD-TTB after the administration of 3 doses over 12-month period was recently measured in 2 pediatric phase 3 trials in Latin America and Southeast Asia. The shortest safety profile was encouragingly benign. However, the efficacy profile during 25 months of disease surveillance was complex.
You may think of mosquitoes as an annoyance, but in most parts of the world they can carry diseases. The Aedes aegypti mosquito carries the dengue virus. More than half the world's population is at risk. On this map, red areas show where outbreaks of dengue fever have occurred. Blue areas indicate regions that are also infested with the Aedes aegypti mosquito, but have not yet experienced outbreaks of the fever. Each year, over 50 million people are infected. Approximately 1 in every 1,000 cases is fatal. To fight the disease, scientists need to understand how the virus attacks at the cellular level. As the female mosquito pierces the skin, searching for blood, it injects saliva and with it, the dengue virus. 7 to 10 days later, the virus has made its way into the bloodstream, infecting more cells and reproducing in large numbers. Each time the dengue virus reproduces, it must release its RNA. Here, inside a human cell, the approaching blue sphere is an endosome. It's actually a piece of the cell membrane that enveloped the virus at the cell's surface and ferried it inside the cell. The cross-section of the endosome reveals the dengue virus, which is covered by a protective shell of proteins. The white plumes are protons being pumped into the endosome. This routine mechanism lowers pH, which in turn causes the viral proteins to change their arrangement, exposing the viral membrane. The proteins shift their shape to form trimers, each made of 3 proteins. The trimers' tips, called fusion loops, stab the endosomal membrane. Once the trimers are anchored in both the endosomal and viral membranes, the proteins fold back on themselves, pulling the 2 membranes together. First, the outer leaflets of each membrane fuse. Then, as the folding back continues, the inner leaflets fuse, and an opening forms called a fusion pore.
Advantage and disadvantage. Advantage. The most striking benefit of vaccines was a large reduction by 67 to 80% in dengue hospitalization. On the other hand, efficacy against any disease caused by serotype 2 viruses ranged from 35 to 50% and was lower. Still, no vaccine recipients who were seronegative at baseline. Disadvantage most eye-catching is the suggestion that CYTTDV vaccination was associated with an elevated risk of hospitalization for dengue among children younger than 9 years of age, but most frequently among just 2 to 5 years of age when they were naturally infected in the third year after vaccination.
This video, I'm going to talk about dengue virus replication and pathophysiology of dengue. So, here we have a man of a tropical country, and we will see how this man will get affected by the dengue. So, dengue is most common in the tropical areas, not in the temperate regions. So, say for instance, this is the dengue virus transmission is called Aedes aegypti. Aedes aegypti. So when the mosquito bites, with its saliva, it injects the dengue virus. Is injected by this mosquito, and there are some dendritic cells beneath this epidermis region. In the dermis, we have some dendritic cell. This is our epidermis, denoting as M psi, and we are denoting it as DC. Also, what we have granule secreting basophils. Dengue virus will actually infect the dendritic cell or the macrophages. So dendritic cell has a particular type of cell receptor called the DC sign, and the macrophages has a particular type of receptor which are Mannose type receptor, MR, Mannose type receptor. So this dengue virus can actually get inside the dendritic cell via either of these 2 receptors. And we will look in details how the dengue virus get inside and cause harm to these kind of cells. However, when these cells are harmed, it will migrate to the lymphoid system to alarm the immune cells. So this dendritic cell is affected. This dendritic cell is affected. So as the macrophage is also affected here, so they will migrate by this the lymph capillary, the lymph vessel. They will migrate via this lymph vessel and go to these capillaries. The immune cells like our cytotoxic T cell, that is CD plus cytotoxic T cell, and also the uh, NK, the natural killer cells will come out, and also the CD8 plus T cells will come out.
Issue applied in Ecuador. So here we have a graphic that describes the percent distribution of dengue regions. In the Mission region, we have 23%, Sierra region, we have 9%, and Coast region, 68%.
My name is Dengueris. Yes, I admit to spreading the dengue virus that has killed hundreds of people across the world. And I confess that I will not stop. You may have caught me, but my sisters are out there doing the good work. Why only my sisters, you ask? Because our brothers are useless. They make all of the women do all the hard work. I am from the clan of Aedes aegypti. There are other mosquito gangs out there, but we are the most dangerous. We are the only ones that carry the dengue virus. All our gang members are recognizable. We all have unique white marks on our legs, like this. My home is in dirty water. We love rainy weather. And all our secret base camps and training camps are in stagnant water. Whenever rainwater collects in puddles, in discarded tires, or in open toilets, we are probably there, loading up on dengue virus. It is monsoon season, and we are stronger than ever. We are coming for you. Beware.
Conclusion. The new evidence from year 3 and 4 of hospital surveillance indicate that children between the age of 9 and 16 years continue to benefit probably because CGDTDB evokes bank serotype immunity in many recipients who have had previous natural infection. Longer-term efficacy results will inform the need for booster doses, if any, in this age group.